Particle theory of matter. In this lesson, we're talking about the 5 particle theory rules. We're going to review matter. We're going to talk about pure substances, including elements and compounds, as well as mixtures, which include homogeneous and heterogeneous mixtures. The particle theory, 5 rules. Number 1, all matter is composed of particles. Number 2, the particles of one substance are the same. The particles of a different substance are different. Number 3, there are attractive forces between particles. Number 4, particles are always moving. And number 5, the more energy particles have, the faster they move and the higher their temperature. Now we're going to go through each one. Rule number 1, all matter is composed of particles. These particles are the smallest pieces of matter that identify a substance. If you take a substance and break it into successive smaller pieces, eventually you will come to the smallest piece, a particle. So in our example here, we have this large red square, and if you break it into really, really small pieces, eventually you'll come up with its component parts. These are going to be the particles that make up the substance. Number 2, the particles of one substance are the same. The particles of a different substance are made of different particles. So for instance, gold particles are all the same and different from silver particles. The particles that make up gold are not the same as the particles that make up silver. The particle theory, rule number 3. There are attractive forces between particles. The closer particles are to each other, the stronger the force of attraction. This is why substances like solids, with particles so strongly attracted to each other, are more rigid and typically more dense than liquids or gases. And for example, ice is going to be more rigid than liquid water. It's going to form the solid ice. Particle theory number 4. Particles are always moving. Regardless of whether or not a substance appears to be still, the particles that make it up are moving. In theory, when this movement stops, a substance has reached its lowest possible temperature. This is called absolute zero, and it's negative 273 degrees Celsius or 0 degree Kelvin. However, we've never been able to reach absolute zero as particles are always moving. Now, the higher their temperature, the faster they're moving. So liquids are moving slower than gases, and that's represented in this picture by the longer arrows. Particle theory rule number 5. The more energy particles have, the faster they move and the higher their temperature. This movement is called heat or heat energy. Temperature is a measurement of the speed of the particles. Higher temperature equals more speed. So you can see as we go from left to right, that's going to be our liquid on our left and our gas on our right. We're going to add energy, and as a result, we're going to move faster. If energy is added or taken away, the substance can change shape. So if we add energy, we're going to go from solid to liquid to gas. And if we remove energy, like if we cool something down, we're going to go from gas to liquid to solid. The classification of matter. These particles are the building blocks of all matter. The combination of these particles leads to the creation of every substance on Earth. People, bridges, birds, everything on Earth revolves around the particles that make it up. Now, how do we classify matter? Scientists classify objects that help organize the vast amount of information found in science. It's similar to how grocery stores organize their products. You're going to have all your produce in one section, all your bakery goods in another, your dairy in a third, etc. All matter in the universe can be classified into 2 basic categories, mixtures and pure substances. A substance must be one or the other. So it's either going to be a pure substance or it's going to be a mixture. It's not going to be a combination of the two, and it's not going to be a third item. Let's start with mixtures. Within mixtures, there's going to be 2 examples. Homogeneous, that's going to be our solutions, and our heterogeneous, that's our mechanical mixtures. Matter that consists of 2 or more substances mixed together but not chemically bonded are called mixtures. Mixtures are matter that consists of 2 or more substances mixed together but not chemically bonded. That's key, not chemically bonded. Mixtures can be homogeneous or heterogeneous. Examples include concrete, sugar, water, seawater, cereal and milk, fog, etc. First up, homogeneous mixtures. Homogeneous mixtures have identical properties throughout the object. They have one phase, so they look like one thing. So examples of that include salt water, tap water, and sugar milk mixtures. Examples include salt water, tap water, and sugar, as well as milk mixtures. So the best example I have is milk. Milk just looks like that one phase, that just white liquid. However, milk is made up of many components mixed together. Heterogeneous mixtures, on the other hand, have different properties at different locations throughout the object. So a good example of that is this salad dressing right here. You can see we have this white part of the salad dressing, we have these little flakes of stuff, we have discoloration throughout. There's more than one phase, it looks like more than one thing. Other examples include concrete, pizza, soup, etc. And if you take a look at this diagram down here, you'll see we have the green circles and we have the white boxes showing different phases within that object. Now we talked about mixtures, how they can be heterogeneous and homogeneous. Now we're going to move on to pure substances. Pure substances can either be elements or compounds. Pure substances are matter that consists of one substance on its own or chemically bonded to another. Pure substances can either be elements or compounds and have one phase, and examples include carbon dioxide, gold, pure water, etc. So let's start with elements. When only one substance makes up an object, it is a pure substance. Elements are the simplest pure substance, and they cannot be chemically altered into smaller substances. The smallest part of an element that still possesses the properties of an element is the atom. So for example, gold is made up of gold atoms only. It is a pure substance. It is only composed of its elements. Each element can be found on the periodic table and has a chemical symbol. The first letter is capitalized and the second letter, if necessary, is not. So for example, Au is gold, Ag is silver, Zn is zinc. All the elements that make up the universe as we know it are found on our periodic table. Compounds. Pure substances are not always single elements. Pure substances can be made up of more than one element that are chemically bonded together. So for example, carbon dioxide is made up of carbon and oxygen. Sodium chloride is made up of sodium and chlorine. Barium chloride is made up of barium and chlorine. H2 is two hydrogens, and H2O includes two hydrogens and one oxygen. The properties of a compound. The properties of a compound are different than the individual atoms that make it up, and a great example of that is salt, which is made up of NaCl. Na, or sodium, is a metal that is explosive in water. If you put sodium out in water, it will explode. Chlorine is a green, poisonous gas. However, when you mix them together, they make up common table salt. To review, all things in the universe other than energy are made up of matter. Matter can be broken down into pure substances and mixtures. Pure substances are broken down into the individual elements, and the compounds, which are elements chemically bonded together. Mixtures, on the other hand, are broken down into homogeneous and heterogeneous mixtures. Homogeneous mixtures are more than one compound mixed together in one phase, whereas heterogeneous mixtures are more than one compounds mixed together in more than one phase. And you can see that represented by the green circles and this other compound here. More than one phase mixed together. And that concludes our lesson on particle theory and the classification of matter.